Remember, solutions are the answers or the x-intercepts for some quadratic function. Okay, so basically we were just looking for where on our graph, where the parabola touched the x-axis, right? Those were our x-intercepts, our solutions, our roots, whatever we want to call them, okay? And whenever it's graphed for us, or if they just give us the equation in the form we want, if we have our graphing calculator, we can graph it to see where it is. But if we don't have a picture of the graph, or we can't graph it ourselves, then I can't see where the x-intercepts are, right? So we have to have another method for being able to find those x-intercepts or those solutions. And one of the ways we can do that is by factoring it, which is what we did last unit. So just a reminder, I wrote down here what our steps for factoring are going to be. Okay, so this first step is kind of new because last unit, they already would have everything on one side of the equal sign for us, right? But here they're saying you need to make sure that whatever they give you, whatever function, ax squared plus bx plus c, it has to be set equal to 0. We don't want anything on the other side of the equation, okay? So that'll be what we do first. Move everything to the correct side of the equation. Then we factor it like normal. So remember, whenever we factor, what do we look for first? GCF, right? And if there is one, we go ahead and take it out, and then we have to identify our sum and our product, right? The middle term and the last term. Remember, it has to multiply to give us the product, add to give us our sum, and then we just write our answer in the two parentheses, right? Okay? Once you have done that, it says you're going to take your factor or your parenthesis, whatever you put in there, if it's x plus 3, and you're going to set it equal to 0 and then solve it. Okay? So, for example, whenever they factored, these were the two factors they came up with. So after they did their two sets of parentheses like this step right here says they're going to take x plus 3 and set it equal to 0. And they're going to take x plus 2 and set it equal to 0. And then step 4 is to solve for x. Well, how could I move that plus 3? To get x by itself right here.
Minus 3.
Just minus 3 from both sides. Good. Okay, so plus 3 and minus 3 go away. What is 0 minus 3? Negative 3. So I would end up with x equals negative 3. Right? I could do the exact same thing for the plus 2. If I want to move the 2 over, I could just subtract 2, and I end up with x equals negative 2. Okay? So this is what steps 3 and 4 are talking about. Okay? All right, so let's give these steps a try in trying to find the x-intercepts or the solutions for this quadratic equation. Okay, so remember, the first thing they said that we need is for it to be set equal to 0. Well, is this set equal to 0?
Yep.
Yeah, so we don't have to do anything there. Then it says to factor it completely, which means to break it down into two sets of parentheses. Have they already done that? Yeah, so it's already factored. So then step 3 says to take each factor and set it equal to 0. So here's my first factor. I have to take 3n minus 4 and set it equal to 0. I have to do the same thing for this parenthesis. Take 3n plus 5 and set it equal to 0. Okay, so step 3 done. We took our factors, set them equal to 0. Step 4 is to solve both of these. Okay, so what would I do first to solve this one? What am I going to move?
Plus 4.
Good. And what is 0 plus 4?
4.
Okay, so I have 3n equals 4. Then what should we do? Very good. And if I divide 4 by 3, is it going to come out as a whole number? So we could just leave it as the fraction 4 over 3. So n is equal to 4 over 3. Okay, so there's my first solution. Okay, got to do the same thing for the other one. So what are we going to do first? Very good. And 0 minus 5 gives us, okay, so 3n equals negative 5. Then what? 5 by 3. Very good. Again, it's not going to come out and give us a nice and neat whole number, so we'll just leave it as n is equal to negative 5 over 3. Okay. So just like when we were looking at the picture, we found two x-intercepts, just like we would have. I was looking at the picture and seeing where it crossed in two places. Okay. All right. Let's do it again. Number 2. First step, make sure it's set equal to 0. Are we good there?
Yes.
Okay. Step 2 is to factor. Okay, this hasn't been factored yet. What do we look for first? Is there one? No. No GCF. Okay. So then what is my sum and my product? Okay. So can anybody think of anything that multiplies to give us negative 28 and will add to give us positive 3? 7 times 4 does give me 28. And I need it to give me a negative 28, so one of those has to be negative. The 4. Very good. 7 plus negative 4 is positive 3. Very good. Okay, so now I need to write these as parentheses. I'll have x plus 7 and x minus 4 equals 0. Okay, so we factored it. What are we supposed to do next? What does step 3 say to do? Right, so here's my first one. X plus 7, set it equal to 0. And do the same for the other. X minus 4 equals 0. And then what's step 4? Very good. So how would I get x by itself on this first one? Okay, so I end up with x equals, very good. Okay, what do I do to solve this second one? Very good. And 0 plus 4 is just, so we end up with x equals, okay. So did we get our two solutions? All right. Okay. Okay, number 3, let's do it again. Okay, what's step 1? Well, step 1 on here, what do they say? Set it equal to 0. So we got to do that before we can get started. Is this currently set equal to 0? So what do I need to do to put a 0 over here? Very good. I'm going to add 3x squared to both sides. So I can move it over here. Okay, is there anything that has a term with a square in it on this side? No. So no like terms, nothing to actually add it to. So I'm just going to have 3x squared. Do I have any terms with just an x? Got negative 12x, so I have to write down that next. And then do I have a constant with no variable? Very good. Is now equal to 0. Okay, so they also didn't have it in the right order. So remember, this is the order we needed them to factor. Okay, we set it equal to 0. Now what do we need to do? Yes, now we look for that GCF. So what is our GCF going to be here? 3. Okay, so I'm going to take out a 3 from each one of these terms. So if I take 3 out of 3x squared, what's left? Very good. If I divide negative 12x by 3, what's left? Good. And if I divide negative 15 by 3, what's left? Nice. Okay. All right, so now that we've done that, what is our sum? Negative 4, good. And what is our product? Nice. Okay, what multiplies to give us -5 and adds to give us -4? Well, the only thing that multiplies to give me 5 is what? 1 times 5. And one of those has to be a negative. Which one? The 5. Very good. All right. Okay, so don't forget we had our GCF of 3, so I put that down first. Times, I'll have x plus 1 and x minus 5. Okay, we factored it. What do we need to do now? Okay, so every single piece. So I'll have 3 equals 0, x plus 1 equals 0, and x minus 5 equals 0. Okay, well, does 3 equal 0? So we don't need this piece, right? Not going to be one of our solutions. Okay, how could I solve for x on this second one? Good. Okay, what is 0 minus 1? Good. So we have x equals -1. And then how are we going to solve that last one? Good. So our last solution is going to be x equals +5. All right. So there's our two solutions. Okay, we got one more here on the front. Okay. So again, what does the first step on our paper say to do? Set it equal to 0. So we're going to need to move that 6x over. How are we going to do that? Very good. Okay, and is x the same thing as x squared? No, so we can't actually put them together. Right? So I'm just going to have 3x squared minus 6x equals 0. Okay? All right, so now that we have it set equal to 0, we need to factor it. So the first thing we should do when factoring is look for a, right, so what is my GCF here? 3 what? 3x, very good. They both have an x in them as well. Okay, so if I divide 3x squared by 3x, what's going to be left? Just x, very good. And if I divide -6x by 3x, what's going to be left? Very good. Okay. Now, do I have an x squared that's left in there? No, so I don't need to factor it now, right? There's supposed to be 3 things in there if I'm looking for sum and product. So I'm done factoring it. So what does the next thing on our paper say to do? Right, so I set each of my pieces equal to 0. So I'm going to have 3x equals 0, and I'm going to have x minus 2 equals 0. Okay? For 3x equals 0, what am I going to do to get x by itself? Very good. And what is 0 divided by 3? Very good. Okay, for that second factor, what am I going to do to solve for x? Very good. So x equals, nice. All right, so I still got my 2 solutions there. All right, now we just got 2 multiple choice questions on the back. So go ahead and flip it over to the back. Okay, number 5 says that the area of a rectangular bedroom is given by the equation 2w squared minus 2w is equal to 12, where w is the width of the room. Find the width and sketch a graph of the related quadratic function. Okay, so first of all, we know that the equation is 2w squared minus 2w equals 12. Okay, and we also know that if we can find the 2 answers, those are going to be x-intercepts on our graph, right? Okay, so we could just solve it the same way we were doing the ones on the front so that we can find our two x-intercepts. Okay, so if I'm going to solve it the same way I did on the front, what are we supposed to do first? Okay, so we need to move the what? Move the 12. Okay, so I'm going to subtract 12. And is there anything that's like 12 over there to actually combine it with? So we'll just have 2w squared minus 2w minus 12 equals 0. Okay, so now we have it set equal to 0. What do we do now? Factor it. Very good. So the first thing we look for is what's my GCF? Nice. So I take 2 out of everything. So 2 out of 2w squared would leave us with, and 2 out of negative 2w would leave us with, nice, and 2 out of negative 12 would leave us with, nice. Okay, so now I look for my sum and my product. What are those? Nice. Okay, so now I have to think, what numbers will multiply to give me negative 6 and add to give me negative 1? Nice. So 2 times negative 3 is negative 6, and 2 plus negative 3 is negative 1. Very good. So I'll have 2, and I'll have w plus 2 in my first parenthesis, and w minus 3 in that second parenthesis. Okay, so we factored it. What are we supposed to do now? Very good. So I've got this 2 that I'm going to set equal to 0. I'm going to set the w plus 2 equal to 0. And I'm going to set the w minus 3 equal to 0. Well, does 2 equal 0? No, so we don't need that piece. Okay? All right, and then how would I get w by itself here? So I end up with w equals, nice. What about for that last one over there? Very good. So we get w equals, nice. Okay, so did we find two x-intercepts here? Okay, remember we said on a graph, an x-intercept is where it touches the x-axis, right? So if I want to draw a picture, I'm going to come over here and graph both of these. So I need to give myself an x-intercept at negative 2, which would be right there. And I also need to give myself an x-intercept at positive 3, which would be right here. Okay? And I'm just giving a rough sketch of the graph. I don't need to be perfect, but I do know that the bottom would be somewhere right in the middle of these, right? And it makes a U shape. So you're just going to draw a sketch of approximately what you think that would look like. So something like this, right? Okay, and they said whatever W is, it's representing the width, right? Okay, width is something that's usually measured in like inches or feet or centimeters, something like that, right? Okay, so they're saying that there's two answers here that we got for possible answers of W. Well, have you ever heard of somebody measuring some wall or some desk or anything and saying that it was negative 2 feet long? No. You can't have negative length, right? So this one would actually not be our width. It would have to be our positive solution. So you can't have negative width or length. All right, so width is 3. And I didn't give us any units, so you can just put 3 units would be fine. All right. Huh? I didn't. I just made a rough sketch. Okay, last one says which statement about this function is true. Okay? Well, if we start reading the answer choices, they found the zeros, right? So obviously we're going to need to find the zeros in order to determine which one of these is true. Okay, so if I'm going to find the zeros, the first thing we have to do is what? What's our first step? Before that, before we factor, set it equal to 0. So I got negative x squared minus 2x plus 15. It's all already on the same side, so I can go ahead and set it equal to 0. Now we're ready to factor. So when we factor, what do we look for first? GCF. Okay? So what kind of a GCF do we have here? Negative, right? We don't want that leading term to be negative, so I'm going to take out a negative 1. Okay, so if I take a negative 1 out of negative x squared, what's it going to become? Very good. And if I take a negative out of negative 2x, what's it going to become? Very good. And if I take a negative out of positive 15, it's going to become nice. All right, so now that we've taken out our GCF, what is our sum and our product?
2 and negative 15.
Very good. Okay, so we need something that multiplies to give us negative 15 and adds to give us positive 2.
3 and negative 3, negative 3.
Very good. So negative 3 times 5 would give us negative 15, and negative 3 plus 5 would give me positive 2. So I've got my GCF of negative 1, and then x minus 3, and x plus 5. Okay, what do I do now to make sure I know what the actual zeros are? Alright, so I got negative 1 equals 0, I got x minus 3 equals 0, and I have x plus 5 equals 0. Well, does negative 1 equal 0? So we don't want that. Okay, how would I solve this one? Add 3, and what is 0 plus 3? Good. And for the last one, what will we do? And 0 minus 5 is? Okay. All right. So can we eliminate any that don't say that x should be negative 5, and x should be negative 5, and x should be positive 3? Is there any that don't say that? A says that the zeros are negative 3 and positive 5, which is not what we got, right? Does B have the right ones?
Yes.
Okay. Does C have the right ones? No. This one's good, but that one's not. And what about D? Nope. The 3's good, but the 5 is not. So our answer must be